Good afternoon. Today I'll be continuing with isometric projections. I'll be solving two problems on isometric projections. We are going to look into combination of solids. One problem I'll be solving wherein we have a prism that is resting on a cylinder, that is placed on a cylinder. That is one combination. And the another one is a rectangular slab upon which I have a pyramid placed. So first problem is as follows. I'll just read the problem statement and then start solving the problem. A regular pentagonal prism of base edge 30 mm and axis 60 mm is mounted centrally over a cylindrical block of 80 mm diameter and 25 mm thick. Draw the isometric projections of the combined solid. I'll repeat the problem statement again. A regular pentagonal prism of base edge 30 mm and axis 60 mm is mounted centrally over a cylindrical block of 80 mm diameter and 25 mm thick. Draw isometric projections of the combined solid. So, we have a pentagonal prism whose base edge measure 30 mm and the axis length is 60 mm. This is mounted centrally on a cylindrical block or this is a cylinder having a diameter of 80 mm and the thickness of this cylinder is 25 mm. So this is the given problem statement. To start with, whenever it comes to isometric projections, you first have to get the orthographic view, that is the front and the top view of this combination of solids. So basically here you can make out that it is basically a cylinder upon which you have a prism. So we will have to get the front and top view of this combination of solids. So to start with, let me first draw the XY line. As I said, first we have to get the orthographic views, that is the front and the top view of this combination of solids. So to start with, I have a pentagonal prism. This pentagonal prism is what I am going to draw first. Now here, as we have observed in planes or solids, wherein it was said that the solid was resting on its edge or it is resting on the corner, and as per to whatever is the problem statement, we used to accordingly place the pentagon. But in this problem statement, nothing like that is specified, so you can rest the pentagon the way you want. So I'll be resting it like this. So we all know how to draw a pentagon. The inside angle is 108 degrees and the edge of each side, the dimension of each edge is 30 mm. Once you get this, as this is a prism, by taking the perpendicular bisectors, you can find the center of this prism. Okay. And then this prism basically is going to have the top face and the bottom face. The top face is overlapping on the bottom face. We can label these with alphabets A, B, C, D, E. So I will label this as A, B, C, D, E. So this is the pentagon. Before I proceed to getting the top view of this, getting the front view of this, I will first complete the top view of the combination of solid. So this is the pentagonal prism in its top view. Next, it is placed on a cylindrical block and it is placed centrally. That is, the center of this pentagon is coinciding with the center of the cylinder. So next is, I am going to draw the cylinder. The top view of the cylinder will just look like a circle and having a diameter of 80 mm. So taking the radius as 40 mm, I will So this is the cylinder having diameter 80. This is the pentagon having the edge dimension as 30 mm. So this is the top view of the combination of solids. Now let us proceed to get the front view of the same. In order to get the front view, we will project this on top. We know how to get the front view and the top view of the solids. Once we do this, what is the thickness of the cylindrical block given, which will be visible in its front view? It is given as 25 mm. So this should be 25 mm. This is the projection. So this, what you see here, is the cylindrical block in its front view. This is the cylindrical block in its front view. This is measuring 25 mm. Next, this pentagon in its top view needs to be projected up so that you can get the front view of this pentagon. For this again, you can start projecting all the points so that you get the base of the pentagon, and then as per the height of it, that is 60 mm, you can just get the top view completed. So if you want, you can get the projection lines, or just by keeping the scale you can mark this point. Also, you'll have to mark the center. So this is the front view of the pentagonal prism. I have not shown the projection lines. You can just take the scale and keep the scale and just mark a point on this, so that we don't have all those projection lines marked here, because that's not required to be shown. Okay, so even if you don't show, that's okay. Next is, you have to mark the dimensions. That is, this is the pentagonal prism. It is 60 mm is the height of this pentagonal prism. So this is the front and the top view of the combination of solid, that is a pentagonal prism, which is placed on a cylindrical block, and it is placed centrally such that the centers of both the cylinder and the prism are going to coincide. So having completed this, now we will proceed and get the isometric projection of this combination of solids. To get the isometric projection, as we know, we have to first start with isometric axis. You draw them like this. You first draw a horizontal line, and by taking a point here, you can mark 30 degrees angle on both the sides. So this is already known to us how to get the isometric axis marked here. Once you do this, next is we have to get the isometric view of this particular combination of solids. In order to get this, first thing, we are going to enclose each solid in a box, because those boxes that we draw, the square box, those lines will be parallel to the isometric axis, and it's very important that you have lines which are drawn parallel to the isometric axis. So here basically first this circle that you see, that is the top view of the cylinder, I am going to put this into a box. Put this into a box, and whenever you're putting it into a box, for every solid you'll have to do this. You have to put all the solids in the boxes, and once you put this in a box, you number the box. 1, 2, 3 and 4. The 4 corners of this box. Now this box need not always be a square, it can be a rectangle as well. Okay, so it need not be a square, you just have to enclose that solid into a box. So first I have enclosed this cylinder, the top view of the cylinder, into a box. Now this box needs to be transferred here in order to get the isometric projection of cylinder. I am first working on cylinder. Now I know cylinder, it is going to have a base and then it has a top face having a certain thickness, that is 25 mm, which is given in the problem statement. So to start with, let me first get the base of the cylindrical block. Now how do I get that? Whenever we go for isometric projections, you either have to observe the complete combination of solid from the left bottom corner or from the right bottom corner. You have options of seeing the solid, combination of solid, either from this end, that is 1, or from 2. Either of the sides, you can go for any of the sides, whichever side you want to go for. Once you do that, now what I'll do, I'm going to refer to this end and I'm going to solve the problem. So when I refer to this end, this point 1 is what will be marked here. Once I mark 1 here, likewise I'll have 2, 3, 4 marks. So on this side I'll get 2, 3 and 4. So first, in order to get the isometric projections, I have to get the ISO scale drawn. So here you will see the ISO scale. We have already known what is this ISO scale. This has an angle of 30 degrees and this has an angle of 45 degrees. This 30 degrees line represents the ISO scale and this is the actual scale. Whenever we go for isometric projections, all the dimensions have to be in ISO scale. So this actual scale is nothing but these dimensions that are there, the actual dimensions, they will be marked on this actual scale, and then by taking a line vertical such that it intersects on this ISO scale, the new reading that you get will be the ISO scale reading that should be marked on the isometric projection part. So first, to start with, taking a compass, you take a compass and measure 1 to 2. This 1 to 2 should then be marked on this actual scale, that is 1 to 2, and this, from this point, wherever that dimension has cut this actual scale, you have to draw a straight line down. Now this is the ISO scale reading that you need to take, which has to be marked on this part. part. So now by taking the compass again, you measure this and that should be marked here. So you have measured 2 here, which by referring to the iso scale. So you have marked point number 2. Next, let me go for 2 to 3. As it is a circle, basically, the square, the box that we get around is a square. It will have all the sides equal. So if you want, you can keep referring to each side again and again, go to the iso scale and get the, go to the actual scale, get the iso scale value, or you know that it is going to be the same throughout because it's a square. You can take the same compass marking and go on marking such that you get 1, 2, 3 and 4. So by taking 2 and 3, again you go here. If you want, mark it here, you'll get the same iso scale reading. From 2, you mark an arc such that you can mark here 3. Now, can I just get any point from 3? No. So from 1 to 4, you see how much is 1 to 4, go to 1 to 4, go to this iso scale, get the new reading, and that you'll have to mark here. So this is 1 to 4, I have marked 4. Likewise, 4 to 3 will be same. You can cut an arc to get the new reading, that is 3. So this is the point of intersection here where we get 3. So I have marked 1, 2, 3 and 4 by referring to the iso scale. In isometric projection, every dimension on the actual scale has to be converted to iso value, that has to be marked. So here basically, instead of going to the iso scale, if you are not comfortable with this, all the actual dimensions you can just multiply by 0.816. The value that you get is this value, the new measurements that I have marked. You either go for this one or you go for this iso scale and mark the iso scale dimensions on this particular. Once you get these points, you have to join it. So this is how you get this square box here. Once you get this, next is you have to get this circle here. In isometric projections, the circle looks like an ellipse. Okay, and in order to draw the circle, may it be the cone, may it be a cylinder, this is how you will be drawing a circle. You will be following the 4-center approximation method. 4-center approximate method is the one which we are going to follow in order to get a circle which basically looks like an ellipse in isometric projection. To draw this, what do we do? First, this square that we have drawn, we are going to get the midpoint of it. How do you get the midpoint? You can get the midpoint of these 4 sides, join them to get the midpoint here. Once you get this midpoint, very important step, the next step is from this end you join this midpoint, this point. From here you join this. Likewise, from 1 you join the midpoint in between 4 and 3, and from 1 again you join the midpoint between 2 and 3. So you get this construction part here. Once you get this, then you can draw the ellipse. How do we draw the ellipse here? I said this is by 4-center approximate method. So there are going to be these 4 centers here that we are going to refer to and complete the ellipse. Take the compass, keep the point on 1 and the other end of the compass here on this end. So this is 1 center of drawing. So this is 1 center. By taking this as the radius, you join the other end. So this is center 1, that is this point. Next, go to the opposite side. This is the second center, center 2. From here, take the compass and you draw by taking this as the radius, you get the other circle, other arc. Next, so this was my center number 2. Next, the third center is going to be here, this. By taking the compass and taking this as the radius, you get this completed. Likewise, this end will be the fourth center. By taking the compass and this as the radius, you complete this. So this is the ellipse that you can see, which is the isometric projection of the cylindrical block. Now I have just completed the base of this cylindrical block. I have to get the top face. So whenever it comes to isometric projections, whenever it comes to solids, it always has these two surfaces, bottom and the top surface. So whenever you're drawing the isometric projection, it's very important that you consider top and bottom surfaces. Both have to be drawn here. Now how do I proceed with this? Now I've just got the base of it. Okay, and remember one thing, whenever you're solving isometric projection problem, you have to draw everything very light. Why? I will let you know later, but initially it has to be all drawn very light. Do not go for darker lines, because final isometric projection only should be shown, the visible edges, the visible sides, the visible faces, only those have to be shown as darker lines. And as there is too much of construction that we are going to come across, all of these lines are going to look very messier if you draw very dark lines. Make sure that you are using a very fine, sharp pencil and you draw everything very light. So these are the 4 centers. I'll repeat again. 1 is here, 2 is here, 3 is here, and 4 is here. By considering these 4 circles, I have joined all the arcs to complete the ellipse. Once you do this, now I have completed the base. Let me now go for the top face of this cylinder. Top face of the cylinder is here itself. It is coinciding with the bottom face. So what I can do next? The same square again I have to draw on top to get the top face. So what I'll do? I know the height of this. It is 25 mm. So take the compass, measure 25 mm, and that 25 mm should be marked on this. From here, you pull it down to get the iso scale value of 25 mm. Again take the compass, and from 2, you can cut an arc here, measuring 25, iso 25. From 1, iso 25. From 4, iso 25. And from 3, iso 25. This I have done so that I can get the square box on for the top face. Okay. So once I have done this, the next thing is take a protractor and from here mark 90 degrees line such that it will cut this line somewhere here, cut the arc, and you get the point here. So basically the idea or what is required here is you should get a straight line, 90 degrees line, such that you can get another square on top, another box on top. From here again, I'll draw 90 degrees line, see where it cuts. This extra arc that is there, I will erase it off. Likewise, I'll see where this is. So now, if you see, I have got 4 new points to mark 1, 2, 3, 4 square for the top face of the cylinder. So next is, I can just join these. This is how I have just joined these. Once I join them, again I have to repeat everything in order to get the ellipse for the top face of the cylinder. For this again, see where is the, so this is 4, 3, 2 and 1. find the midpoint of 1 and 4, find the midpoint of 4 and 3, find the midpoint on 3 and 2, and midpoint on 2 and 1, so that you can get the center again. So we will get the center. Once we get the center, from 3 you join it to the new center. From 1 you join it to the new centers, and then again by taking the compass, by taking this as the radius, you have to get this arc by the 4 center method. Now this basically looks very complicated as I am using different color chalks, but I cannot make it very light because it will not be visible otherwise. It does look very confusing, but if you have understood the very first step of how to get the base of it, you just develop, just project it on top to get the next, the top surface box, and then by repeating the same method, by getting the center of it, and then by connecting all the midpoints to the 4 centers that I have mentioned, you can get the top surface as well. Once you get this top surface, you can see here, you have got one ellipse and another ellipse. These 2 ellipses should be joined together by tangents. So these are the tangents that you see. Take a scale and just join one point on this ellipse and other point on this ellipse such that they are tangents here. So this is how you get the cylindrical block in isometric projection. So now here, as I said, I am here, I am observing it from here. So this is the cylindrical block which will look like an ellipse in its isometric view. Next, now we have to proceed in order to get the prism that has to be drawn. In order to get the prism, because this looks a little too complicated here, I'll just erase off, but when you have to solve the problems, whenever you're solving the problems, make sure that you do not erase any of the construction lines, they all have to be retained. So here, in order to avoid confusion, I am just going to erase off these lines so that this will help you understand better. But again, I'm repeating, when you are solving the same on, whenever you're solving the same, make sure that all the construction lines are retained. You're not supposed to erase any of it. So this is the cylindrical block that you see. I have just erased off all the construction lines so that it will be easy for you to understand the next step. So in order to proceed with the next step, wherein you have to draw the prism which has to be placed on it such that its centers are coinciding with each other. So here basically, to start with, you get the square of this pentagonal base. You first have to enclose this pentagon into a square. Also, again we'll number this. This was 1, 2, 3, 4. I'll number this as 5, 6, 7 and 8. Now this 5, 6, 7 and 8, as I'm observing from here, 5 has to be here. So first, I have the center already marked. This is the center. In order to draw the square, along the center I can just get these lines drawn through the center it has to pass, such that I can draw these lines here. So this is how these lines will be. Next, from this point, I'll just mark this as W, X, Y and Z. This W is what you see here. So W, X, Y and Z is what I have marked here. From W you measure 8, go to the iso scale, mark it here and then project it down to get the new value. So from W to 8 you will cut an arc here. Next, from W to 5, see what is the dimension, get the iso scale, and from W to 5 you cut an arc here. Likewise you do it for all the other sides from that particular. Remember, in isometric projections it's very important that you draw mark the iso scale values with respect to those lines which are parallel to the isometric axis. If any of the lines, for example E to D, it is not parallel to isometric axis, you cannot measure this, take the iso value and mark it. You cannot do that. You have to mark only those lines which are basically parallel to the isometric axis. So having done this, you will get a square here, such that this is 5, 6, 7 and 8. So this is the bottom. This construction is basically done in order to get the bottom of this pentagonal prism. So to start with, I have to start marking A, B, C, D on that square. Again refer to the iso scale values. You keep the compass on 5. 5 to A you measure, get the iso reading of it and you have to mark A. Like that, see how much is 5 to B. Go to the iso scale, see what is the reading, see what is the value, mark B. So this is A, B, this will be C, this will be D and here this is E. So now what we are marking is the base of the pentagonal prism. This is the base of the pentagonal prism. Once you get the base of the pentagonal prism, getting the top face becomes very easy because it's a prism. The top face is just going to lie above it. What we can do is, we know that the height of this prism is 60. Go take a compass, measure 60, mark it here and get the iso reading. And the same can be marked here, iso 60. Okay, once you mark iso 60, take a protractor, see 90 degrees, mark a 90 degrees angle such that it coincides here and what you get is the axis. Once you get this, now I know one thing, that all these ends are going to be 60 mm, iso 60 mm above this base. So what I can do is, from 5 I can measure 60 and I can mark end 5. So what have I done? What you have to do basically, take the ISO 60 and you start marking ISO 60 such that you get this square right above it, right above this 5, 6, 7, 8 square you have to draw on top. After you get this, next again it's all simple. You can again go for individual measurements, go to the ISO scale, or you have the reference already here. From here you can start marking A, B, C, D and E and complete the top face of this pentagonal prism. So you have got the bottom face, you have got the top face of this pentagonal prism. Not looking correct here. I'll just redraw this. So this is A, B, C, D and E, and this is 5, 6, 7 and 8. So I've got the top and the bottom faces of the prism. Next is I'm just going to join E to E, A to A, B to B, C to C and D to D. So this is the pentagonal prism which is going to rest on a cylindrical block. So this is how the isometric projection has to be drawn. The last step, the final step, whenever it comes to isometric projections, you have to only darken those edges, those faces which are, not faces, only the edges which are visible. So you are standing here, you are the observer here, you are the observer, you are seeing it from here. Whatever is visible has to be shown as dark. So I am using this white chalk, if you can see, whatever is visible, that is this top surface of the cylinder, but half of it, because prism is placed on it, what is behind is not visible. So let that all remain light. Next, this tangent is visible. Also, the lower portion of this cylinder is visible. What about the inside one? The inside arc is not visible. Next, what about this prism? You have these edges EA, AB visible. Next, the edge EE is visible. Edge AA is visible. Edge B is visible. So only these three edges are visible. If you see CC and DD, they are not visible. You need not show them as hidden. You need not show them as hidden. You just have to show them light. Whatever is visible, show it dark. And what about the top face? The top face will be completely visible. So this is how the isometric projection has to be completed with respect to the combination of this solid, that is a cylinder that is having a prism on it. So moving on to the next problem. So this problem that I have just solved, it is problem number 8 from the manual. Moving on to the next, that is problem number 35 from the manual. This is yet another simple example which says that there is a pentagonal pyramid, base side 25 mm and height 65 mm is placed centrally on the rectangular slab 100 mm into 60 mm and 20 mm thick. Draw the isometric projection of the combination. So we have a rectangular slab which is measuring 100 mm into 60 mm. Upon that we have a pentagonal pyramid that is kept. So This is the second problem, which is problem number 35 from the manual. We have a pentagonal pyramid. This pentagonal pyramid has sides or edges 25 mm and height is 65 mm. This is placed on a rectangular slab. This rectangular slab is having dimensions 100 mm into 60 mm, and this is 20 mm thick. So to start with, first let us draw the XY line. Mark VPHP. So first we will draw the pentagonal pyramid. To draw the pentagonal pyramid, we know how to draw the pyramid. This will be the center of it. Having marked the center of it, as it's a pyramid, you have to show all the slant edges. In prism that's not required, but in pentagonal pyramid that is required. Any pyramid basically, the slant edges have to be shown. Once you get this, you know the dimensions. Don't forget to mark the dimensions. 25 mm is the dimension of it. Next you have to place you have to draw a rectangular slab. Having known that this is the center of it, you can measure 100 like this and 60 like this. Okay, vertically 60, horizontally 100. So from here, from the center, 5 centimeters this side, 5 centimeters this side, that is 50 mm on this side, 50 mm on this side. You can just mark a line. Likewise, 30 mm above, 30 mm below. From the center, you will get the the rectangular slab in its top view. So this is the rectangular slab in its top view. You can see it here. So this is 100 mm. This is 60 mm, and the sides of each pentagon are 25 mm. Next, let us get the front view of this. We know that the thickness of the slab is 20 mm. So measure 20 mm, get this. Next, you have to get the front view of this pentagon. As I said, I am not marking all the projection lines. You can just take a scale and start marking these points. So once you get these points, you know this is the center. What is the height of it? 65 mm. Once you get this, you just have to join it to the apex of this pyramid. So this is the pentagonal pyramid in its front view, in the top view. This is the front view of the rectangular slab. This is the top view of the rectangular slab. Next is, again I will label this as A, B, C, D and E, with this as O01. And then this is the rectangle. I would have labeled it as A, B, C, D, but not required, because we will directly start with the solution here. If you want, you can mark it, no doubt. Again, take this point and draw 30 degrees and 30 degrees, which is the procedure to get the isometric projection. After this, as I said, I am going to observe for isometric projection. You either observe from this end or this end. So I am observing from here. So this will be my point 1. Now, this is a rectangular slab. Had this been any other solid, you would have enclosed it into a square box. The same you have to do for this rectangular slab also, but as it's a rectangle, you need not again draw a rectangle around it. So the same can be considered as a box, and you can continue with the solution. So this is 1, 2, 3 and 4. So I have marked this as 1, 2, 3 and 4. As I am seeing from here, this is 1. Okay, next, measure 1 to 2, go to the ISO scale, mark it here, project it down to get the ISO reading, and 1 to 2, which is here, you mark 0.2 here. Okay, so you get this as 0.2, you get this as the point. Next, you see how much is 1 to 4, go to the scale here, get that value and mark 1 to 4. So this is 4. Next, see how much is 4 to 3, go to the ISO scale and then you mark that here. So you are getting this 0.3. Next, you just have to join all the points. So this is the bottom of the rectangular slab. So this is 4, 3, 2 and 1. Once you do this, what is the next step that we have to do? We have to get the top. As this is itself the base of the rectangle, you need not again overlap with any other box. You can straight away draw it here. So as you have got 1, 2, 3, 4, I have to get the top face of it. To get the top face, again we'll repeat the same thing that we had done in the previous problem. You know the height of this is 25. The height of this is 25. Take 25, go to the ISO scale, get the ISO value and mark it here. So I'll get ISO 25 marked here. Once you do that, with the help of a protractor, get a straight line, vertical line drawn here. So once you draw this vertical line such that you are getting all the 4 points again, that is 1, 2, 3 and 4. Once you get these 4 points, you simply have to join these points such that you will get the rectangular slab. Okay, so if you can see, it is a rectangular slab. Please excuse me for all the not so proportionate drawing. So this is how you get the rectangular slab. Having completed this, the next step, you have to go for drawing this pentagonal pyramid. Now to proceed with pentagonal pyramid, again you have to enclose the pentagon in a square, in a box, not necessarily a square. Enclose this into a box. So once you enclose this into a box, again number it, this is already numbered as 1, 2, 3, 4. The next box I'll number it as 5, 6, 7 and 8. Now, find the center of this, get the midpoints of all these lines so that you can get the center of this rectangular box. This is the center. Okay, so once you get this, I will get similar center here also. I will just draw these lines such that I can mark this as W, X, Y and Z. So this what I have marked here somewhere is my W, X, Y and Z. Okay, now from W you see how much is 8, go to this ISO scale and get the new value. So from W, okay, before that we don't know where is W. From the center you measure W, go to the ISO scale. So from this you mark here. So this is W. Likewise you do for all. From here you see where is Y, you mark it by referring to the isoscale, you mark this as Y, Z and X. So having done that, you will so these extra lines, I'll just erase them off in order to avoid any sort of confusion here. But in your solutions, in your book, you will have to show all these lines, let them all be there, and therefore I'm telling you to please see to it that you are going to draw everything very light. It should not be dark. Once you get the square for the bottom of this, the base of this pentagonal pyramid, then you start marking 5 to A. You go to the isoscale. So sorry, this is 5, 6, 7 and 8. From 5 to A, go to the isoscale, you will get A. Similarly, you measure B, C, D, and here you have E. So once you get all these points, you have to simply join them, A, B, C, D and E. So this is the pentagonal base of the pyramid. Once you do this, you already know where is the center of it. You know the center. You know what is the height of it. It is, the height of this is 65. Measure 65, go to the isoscale, get the isoscale reading. From here, you mark ISO 65 arc. Then by taking a protractor, taking this as the center, you mark 90 degrees so that you can get the center of this pyramid. Once you get the center of the pyramid, you need not again get the top face because the pyramid here is going to have an apex. So in order to join the apex, you can simply start joining all the ends like this. Okay, so this is O1, this is O. All the markings and all that have been made, it's only for the construction point of view. You need not show the markings, but make sure that all the construction lines are retained. You need not erase any of the construction lines. All have to be drawn very light, and only what is visible finally has to be shown dark. So as I said, we are the observers here. We are going to observe from here basically. So what is visible? This complete, I'm using an yellow chalk in order to show all the visible edges of this solid combination. So this is all visible. Yes, this is all visible. You can erase off the extra lines and edges if they are not required. Now, from here, you will be drawing only till this part. You don't have to complete it. And from here it is. Okay, once this is done, then we will see what is visible in this pentagon. Pentagon, A to B is visible, B to C is visible, and A to E is visible. Whereas E to D and D to C, it is hidden. You need not show it as hidden lines. And then these slant edges, E to O, A to O, B to O and C to O are visible. D to O is, again it is behind. You need not show it as hidden, but you have to show it as a light line. Okay, so this is how you have to complete the isometric projections. So today we have seen how a cylinder needs to be drawn, how a pentagonal pyramid, how a pentagonal prism and a square block can be drawn in isometric projections. So I will stop here.